Given that P and Q are integers such that PQ is even, use algebra to prove by contradiction that at least one of P or Q is even. So we need to set up a contradiction. So we need to say that they are both odd. So we're going to assume they're both odd. P and Q are both odd. And then we're going to show that PQ can't be even, therefore it's a contradiction. So let P and Q be odd. And how can we do that? How can we make P and Q odd? We can say P is 2 times an even number plus 1. That makes it an odd number. And Q is 2 times a different even number plus 1. So they're both odd. We're assuming they're both odd. And then we're going to show that this is a contradiction. So P times Q. So P times Q will be 2n plus 1 times 2m plus 1, which is 4nm plus 2n plus 2m plus 1. And that will be an odd number because an even number is in the 2 times table and it's plus 1. So PQ is odd if P and Q are odd. PQ is odd. Therefore, we have a contradiction and one of P or Q must be even. So for the second part, we've got given that x and y are integers such that x is less than 0, x is negative, and x plus y squared is less than 9x squared plus y squared. And we need to show that y is bigger than 4x. So we're going to just use algebra here. We're going to simplify this. That x plus y squared, square it. So we've got x squared plus xy plus xy plus y squared from expanding the brackets. So we have x squared plus 2xy's plus y squared is less than 9x squared plus y squared. Our y squareds are going to cancel, and we can take an x squared away from both sides. So we've got 2xy is less than 8x squareds. We've been told in the question that x is negative. X is a negative number. So x isn't 0, so we can divide both sides by x. And if it's negative, when you divide or times by a negative, the inequality sign is going to flip over. So if we divide both sides by x, we will get 2y, and the sign's going to flip over. So it is bigger than 8x. As we just half both sides, y is bigger than 4x.